Now, see here combination of cells. So, first one we can take here the series combination. So, in series combination, just we take two cells. Suppose one cell is like this having EMF and internal resistance R1, another cell is like this is EMF here, E2 here, and that is internal resistance R2. Now, this is the point A, this is the point B, and this is the point C. These two cells are connected in such a way that the negative of the first cell is connected to the positive of the second one. So, this is known as series combination of the cells. Now, from here we can write current, suppose it is flowing here I. So, we can write V A minus V B. We assume here the resistance is connected or the circuit is complete when the current is flowing. Now, V A minus V B can be written here EMF minus IR1, and also we can write V B minus V C is equal to EMF of the second cell minus IR2. When we add these two, so obviously this and this will be getting cancelled. So, we will be getting V A minus V C is equal to EMF of the first cell plus EMF of the second cell minus R1 plus R2. Now, this is V A minus V C is the potential difference between the end of these two, where this combination of the two cells are working. So, we can write here basically V A minus V C, that is V A C is equal to EMF equivalent minus IR equivalent. So, here EMF equivalent is here the sum of the EMF of these two cells, and R equivalent is actually the sum of the internal resistances of these two cells. So, this is about here the net EMF increases in this case, but suppose by mistake are you connecting here like this, one cell in this way having the EMF and another cell is connected like this, then the net EMF or equivalent EMF will become EMF of the first cell minus EMF of the second cell here. So, here this is greater than this is this. So, if this is not a series combination here, in that case we take here, and this is the series combination where we take the equivalent EMF is the sum of the EMF of the two cells.